Hello everyone, welcome to my YouTube channel. So in this session, we will see the queues and circular queues implementation. I have taken these slides from the research paper Enhancement of Data Security Using Circular Queues Based Encryption Algorithm. So introduction, um, when we talk about circular queue, it is an abstract data type that contains a collection of data which allows addition of data at the end of a queue and removal of the data at the beginning of the queue. And circular queue have a fixed size. So circular queue may be a linear system within which operation area unit is performed with the support of FIFO, that is first in first out principle, and therefore the last position is connected back to the first position to make a circle, and we so call it as circular queue. So importance of this circular queue. So the queue items are added at the rear end and the items are deleted at the front end of the circular queue. The circular queue has two pointers, uh, front and rear, that keep track of front and rear positions respectively. When an element is inquired, meaning inserted at the rear end, will be incremented. When an element is decayed, meaning the if an element is deleted, then the front is incremented. When the rear reaches the end of the array, it wraps around to the beginning, and similarly, when the front reaches the end, it wraps around to the beginning, forming the circular behavior. So here, that what happens exactly in the circular queue. Once the rear end is completed, it wraps around again to form a circular queue. So the similar things happens here in the front end too. Once it is completed or completion of the front end to the zero, so next front end will be incremented. So this is how new element can be inserted by incremented rear end. So when we talk about abstract data type, ADT, it is a data type where a data type is defined by its behavior semantics from the point of view of a user of the data, especially in the terms of possible values, possible operations on data of this type, and the behavior of the operations. So, for example, for the ADT, we define the values like -2, -1, 0, 1, 2, these are all can be performs operations of addition, subtraction, multiplication, division together with a greater than, lesser than, which is all comparison operators which have according to familiar mathematics. So now we'll talk about abstract stack and queues. We will differentiate between abstract stack and queues here. The abstract stack, which is LIFO, last in, first out, structure, could be defined by three operations. We use here push, pop, add, and display. So in order, we generally use push, where the data item can be inserted into the uh, stack. From the pop, you can remove a data item from it, and peek on the top, we can access the data items on the top of the stacks without removal of the bottom items. which below the top. When we talk about abstract queue, which is first in first out structures, meaning the once the whatever the inserted at the first will be deleted first. So here and queue meaning insertion of a data item into the queue. When we talk about dequeue, it refers to the removal of the first data item from it. As we said, it is first in first out. And front that will be accesses and serves the first data item in the queue. So advantages of circular queue. In circular queue, we utilize memory efficiently. It uses the memory efficiently because in queue, when we delete any element only, front will be incremented by one, but the position is not used later. So when we perform more addition and deletion operation, memory wastage you know, will be more. So in order to avoid this, we use circular queues so that circular queue memory is utilized if we delete any element that position is used later because it is circular. So no wastage of memory take place in circular queue. Another thing is it also allows for efficient insertions and deletion of operations as the elements are sorted in a circular manner and eliminating the need for shifting element when performing operations. So one of the disadvantage of circular queue as uh, a limitation for it is it have only fixed side of the underlining array and it can only hold a maximum number of elements that is equal to the size of the array minus 1. And another thing that talks about disadvantage of circular queue is once the loop enters in a circular queue, it may end up with infinite loop. So these are the disadvantage of circular queue. Next, we'll talk about implementation of circular queue. In this, we have first step where we include all the header files which are used in the program and we define a size, a constant size for whole program with specified value. And we're gonna declare all the defined, user defined functions like integer data types, like which is our primitive data types that we have. We all declare those data type and also will declare the functions that can be used for circular queue implementation. In this slide only we'll see that too for insertion, deletion, displaying, and not to check peak in stacks but not in queues. So next steps 3 is to create a one-dimensional array with above defined defined size. So whatever the size that is defined at the header file, same it is taken up by the queue not to not to build the array. So in step 4, what we do is define two integer value that are integer variables like front and rear, where initialize the both value with -1. In some cases, we'll take front as 0 and rear as -1. And either we can take front is equal to -1 and rear is also -1. Implement main method by displaying menu of operations, list and make suitable function calls in order to perform operation that are selected by the users on the circular queue. So what are all the method we need to apply in order to display the menu? Uh, what we done the operation like insertion and deletion, so that suitable function will be called, and finally they are added with the main function in order to display it. So inserting value into the circular queue. So how we're gonna insert the value to the queue? So here we have. So we'll use enqueue. It is another name for insertion. It is a function which going to be used for insertion of an element into the circular queue. In a circular queue, the new element is always inserted at the rear position, that is -1, and the enqueue functions that takes one integer value as a parameter and insert the value into the circular queue. And we can use the following steps in order to insert an element into the circular queue. Here are the steps uh, which we need to conduct for insertion of a element into the queue. So first step is to check whether queue is full or not. So for that we're gonna use rare, that is equal to, that is equal to, which is a comparison equal operation we're gonna use, where rare is equal to size minus 1. Size, uh, you know what we had been, what we had defined in the header file, that size will be taken off and it's going to be minused by 1, because the rare will be at -1. So when we take the, when size is, so that uh, it want to know whether the queue is full or not, and we're gonna use ampersand, double ampersand. After that we have front, which is 0. So front, then front will become rare plus 1. So next we use, so if this satisfy, then the uh, you know uh, the compiler will come out of the loop. So the if statement will be executed so that it prints queue is full. Else it will move to, uh, it will display the queue is full and insertion is not possible and terminate the function. So if it is not full, I mean the else statement, then it will check rare is equal to size minus 1, ampersand of ampersand front is not equal to 0, means there is a place. Okay, if it is true, then set rare is equal to -1, meaning rare will be at the beginning. So next we're gonna increment rare value by 1. So as we increment, it moves to next position of the rare. So set q of rare, that is equal to value, and check front. Front will be, now it is -1. If it's true, then set front is equal to 0. Here we have taken front is equal to -1. It's actually 0, and the front will increment it and it will become 1. Deleting a value from circular queue. In a circular queue, dequeue is a function that is used to delete an element from the circular queue. In a circular queue, the element is always deleted from the front position. So as we said, it is first in, first out. So whatever the element that are inserted at first will be deleted at first, and not like the stack. What the where the element is inserted at last is, it is not deleted at, first, like that. The dequeue function, which is a del function for queue, doesn't take any value as parameter. It is a main important thing here. So we can use the following steps in order to delete the element from the queue. So the first step is to check whether queue is empty or not. So in order to do this, we first set front, that will be equal to equal to minus 1, ampersand ampersand rare, that is equal to minus 1. So we'll set front to be, you know, minus 1 and red to be minus 1. It could be front to be 0 and red to be minus 1. So it shows that uh, if it's empty, then it shows that queue is empty. So deletion is not possible as there is nothing in the queue. So no element. If there is no element, nothing can be deleted from the queue. So terminate the function and compiler come out of the loop. So if it is not empty and if there is some uh, values that occupied in the queue, then we use display queue front as deleted element and increment the front value by 1. So front will be incremented. Then we're gonna check whether front that is equal to size or not. If it is true, if it's equal, then we set front is equal to 0. Then check whether both front minus 1 and rear are equal. That is front minus 1, that could be front of 0, that will be equal to rear. If it is true, then set both front and rear to be minus 1. So the front and rear will become minus 1. So the deletion can be taken place. Displays, displaying of the elements of a circular cube. So in order to display here, we have to repeat same thing what we have done for deletion. Mainly because if there is some values in this tags, only then we can uh, display the values of that particular queues, or else we could not display. So if it first check for queue is queue have some elements or not. If not, it will come out of the loop. It happens like this. So check whether queue is empty, that is front will be minus 1. If it is empty, then the display queue is empty and terminate the function. If it is not empty, then it is defined an integer value I and set I is equal to front. So then it will check whether front is lesser or equal to rear. If it is true, meaning that if front could be 0 and rear could be a bit greater than the front, then it display q of I value and it will be incremented by 1. I will be incremented by 1 and repeat the same until I, that I particularly become less than the rear. So it will terminate to be, when it terminates to be, when it becomes false, then the compiler come out of the loop for the incrementation statement. If front is lesser or equal to rear, it is false, then display q of I value and it will increment I value by 1. So it will repeat the same until I is less than size minus 1 becomes false. So next we set I to 0 so that no incrementation will be takes place. So again displaying of the q of I value takes place and incrementation of I value by 1 will be taken place and repeat the same until I is lesser or equal to rear becomes false. This is how we can display the circular queue. Here how the circular queue is represented. So here we have an application uh, like based on the circular queue that we had been taken from the research paper, that is enhancement of data security using circular queue encryption algorithm. In this we have data security that will refers to the method of protection knowledge from unauthorized access and knowledge corruption throughout its life cycle. So we're gonna use circular queue as a data structure can be used utilizing in the data security in order to make figured message progressively hard to interpret it. Thank you.